Today we're going to talk about the basics of an orbit. Last time we talked about ballistic motion, and today we're going to talk about how ballistic motion and orbits are related to each other. So recall that ballistic motion is basically where a rocket goes up and then it comes back down. It doesn't have enough energy to actually get into orbit. And so ballistic motion is basically where something is affected by gravity only. The vertical motion of the object is disconnected from the horizontal motion of the object. They're independent from each other. And so when the ball is going, it has horizontal motion and it has vertical motion. That vertical motion is being pulled down. The ball is being pulled down by gravity, but it's moving horizontally also. And if the velocity of the ball starts out as being very small, then it falls to the ground and it doesn't move very far to the right. But if the velocity is medium, it moves a little bit further. And if the velocity is large, it moves even further in the time that it takes gravity to pull it down. So that's one of the fundamental concepts that we have to get. The velocity, the horizontal velocity, is connected to gravity in terms of if something's moving very slow, it falls to the ground and it doesn't move very far horizontally. But if the faster it goes, the further along it can travel before it falls to the ground. So we could make a hole in the ground so it never actually hit the ground. And if something is moving slower, that hole would be steep. If something's moving faster, that hole would be shallower. The Earth, if we zoom out, the Earth is actually shaped, right? Because it's round. And so you could think about the ball as going horizontally, and it's always falling towards the Earth, okay? But it never hits the Earth because the Earth is round. And so it moves horizontally and it's constantly falling towards the Earth, but it never actually hits the Earth. And that's the fundamental concept of an orbit. So an orbit is the thing moving horizontally at just the right speed to make it so it constantly misses the Earth. So if the ball is moving a little bit too fast, that means that what will happen is that the ball will go a little bit higher at one part of the orbit and it will come back lower at the other part of the orbit. If the ball is moving a little bit too slow, it will come towards the Earth down below and then it will come back up to its original spot. If it's moving way too fast, it will just escape the Earth. So how fast is orbital speed? So this is the formula, v equals the square root of gm over r. And usually the g and the m are combined to make this variable that's called mu. And mu for the Earth is defined here, 3.99 times 10 to the 14th. So if you plug in some numbers into this equation, what you get is that the radius is equal to 6371, which is the radius of the Earth in kilometers, plus 400 kilometers, which is low Earth orbit. That's where the International Space Station is. And that is 6,771 kilometers, or 6,771,000 meters. And then you plug that into the equation, and you get the velocity is 7.6 kilometers per second, or 27,635 kilometers per hour, which is 17,000 miles an hour. We can then use this information to figure out how long it takes this space station, for example, to go around the Earth. And what you could do is you calculate the distance that it takes, or that it's moving around the Earth, which is this 42,000 kilometers. And then you can calculate the time given distance divided by velocity. And so the distance is 42,542 kilometers. The speed is 27,635 kilometers per hour. And then when you solve that, you get 1.54 hours. So it's about 90 minutes. And that means that it has about 15 orbits per day, or they see 15 sunrises and 15 sunsets every single day. So then there's a question of, is there gravity in space? Remember earlier in this lesson, we talked about the fact that the International Space Station, or a satellite in orbit, is moving around the Earth, and gravity is constantly pulling it towards the Earth. And so it's got enough horizontal velocity that it always falls towards the Earth. It never hits the Earth. And so it has the exact right velocity to stay like 400 kilometers above the Earth. And if gravity went away, then it would just move away from Earth. There's nothing that would hold it to the Earth. And so it wouldn't just circle the Earth, it would just go off in a straight line. And so there has to be gravity in space. Gravity is the thing that's holding the moon to the Earth. It's holding the International Space Station to Earth. So in summary, an orbit is just an object falling towards something, but it has enough horizontal velocity that it constantly misses it. The horizontal velocity needed for low Earth orbit is about 27,000 kilometers per hour, or 17,000 miles per hour. So that's very, very, very fast. And yes, there is gravity in space. So up next, we're going to talk more about orbits and Kepler's laws, which help us to understand how orbits work in space.